For today's webinar, we are going to do some reverse engineering on an aircraft fuselage. And as you'll see here in this one, we're going to do stuff. This is a larger sized object, and we're going to do a section of a fuselage. And we're going to talk about a few different techniques that were utilized on this piece of geometry. Now, on the surface, this piece of geometry looks quite simple, but with a lot of features. And that is true. That is the majority of what this one is. This one is a brute force, lots of labor of love to model this entire thing. But there were some novel modeling tactics that I wanted to cover while we go through this one. So with that, we'll just jump over to this next slide. As you can see, we 3D scanned a section of a fuselage. We have a section of a fuselage that we use for trade shows, and we went ahead and 3D scanned it, and we're utilizing this as a sample data set to show different modeling techniques and stuff, as well as using it to show techniques for modeling or measuring for metrology purposes. So that's what we have this hanging up there, is you can 3D scan it or use a tracker to touch and align and extract dimensions from it. So we figured we would scan it and reverse engineer it. In this instance, I don't have the project entirely complete, but there were some really neat workflows in here that I wanted to discuss. So we will jump over to the next slide, which, as usual, is going to be our DX workflow slides. As usual, before we get started with our DesignX portion of our webinar, I always like to bring up this slide. I know for some people that watch weekly, this slide can get a little redundant, but we just wanted to make sure that everyone that jumps on the webinar understands the workflow and where DesignX fits in here. So as you can see here on the left-hand side, we have different types of 3D scanners, and DesignX has the ability to connect to those scanners with plugins and import tools. And we have done it for over 30 years, so we have every kind of importer, file type, plugin imaginable to connect to these different types of 3D scanners. And then DesignX is really a CAD platform that utilizes our own scan kernel that we have built from the ground up internally that allows us to handle all that scan data as native entities, bring that in, process it in a way that we can extract model information from it, whether it's CAD model information. Sometimes people want to go straight over to additive, as you can see on the right-hand side. But many times people want to extract CAD model information, both design intent or as built, and send that over to CAD. So by far the top section there is the number one output, where we have a live transfer tool that will allow you to transfer over the CAD information as native entities over to these different CAD platforms. The second one down is we can then save out models like step, IGESat, neutral, all these different native interchange formats to send over straight to CNC packages for cutting stuff directly, or additive. Some additive packages will take CAD models or meshes, and we can save out to those as well. But that's what DesignX's overall workflow is to handle that heavy lifting of grabbing scan data, bringing it in, processing it, extracting just the CAD information or 3D model information that you need, and sending it out to the proper output. Now, there's a whole other host of things that you could probably do. These are just the highlights of the different applications that we send out to on a routine basis. So with that, we'll go ahead and jump over to DesignX for our presentation. So here is the fuselage as we rotate it around, and you see here that we've modeled a bunch of it, and this is the result that we've created. And here is the scan data as well. And we'll just roll back and go through this. And I wanted to highlight a few different specific topics along the way, which I'll hit as we go. So with that, we'll go ahead and roll back, and we will get started. So right out of the gate here, these first few, we have a loft that we've created that was with the loft wizard for the actual fuselage skin. So there's a few different ways you can do that. I wanted to pause and highlight that. So one, we'll just go ahead and turn that one off. When we zoom in here, we can take a look at what that surface is, and you can highlight and select, if these are all the surfaces you want to work with, you can use this crease angle selector tool to select all of those. Now look at what happened here when I selected. You'll notice that there's a couple different heights here. So this is the height that we are interested in. This is the surface, and then there are some pockets that are cut out of that. So you can go around and you can highlight. If I just look around there and make the determination what it is that you want to select there. Another option is I can come around here and select this and go around that way, holding shift and selecting all of these areas to create that bottom surface. Again here, just capture enough of this. Then come around inside here and grab some of those. To create that back surface. And just do this here. There we go. And come over to region, create those as a region. And just for the sake of time, you see here that you have to go around and identify all the areas that you believe are part of that area. And then you come over and do a loft wizard. Orient the box. So if you wanted to do it in a vertical fashion here, and the nice thing about the loft wizard is the fact that it's editable later, right? That I can orient this box around the outside and hit next, and create a nice smooth surface that I can also go back and edit the cross sections for too. So there is my, just do this. There's my surface. Hit OK, accept it. You see we have a beautiful surface there. There's a bunch of different ways you could go about doing it. I did it in a pretty quick way where I just extracted it. Now the other thing that I like to do here is I'll turn my regions off, and if I wanted to trim this surface to the boundary shape and then thicken it, we can go ahead and toggle the surface off. One way that I have, if I'm just trying to trim the outer surface really quickly, one thing that I can do is come in and use, you have the 3D mesh sketch, which I've discussed at length in these webinars. Another one is just the 3D sketch. If I just want to quickly trim that surface, I can come over here to spline. And the nice thing about this is when I click on the surface here, I am clicking on a surface and it's not going to fit the intermediate points with this method here. So I can, if I just want to know where this edge is generally and trim that surface with it, you'll see here that I can come through and create that. And I can do a couple things. I can get out of there and turn on that surface again. And you can come over to trim surface and use this as a tool entity and this as a target entity. And you notice I didn't even extend it, and then I just say keep that. So I wanted to do this really fast, but I would do that all the way around the outside where I just, you see that I just selected 4 points and trim. And since I'm just trimming this off, I'm just kind of cutting it off. I use this as a quick way of coming around the outside and trimming this surface. And then from there, so I'll just do it really fast in this instance here. We'll do this one more time. Turn that off. Let's just look at this. I can click. Let's just say I want to trim from here. I just want to make a straight line all the way across there. And we'll do it one more time over here. Let's just say I want to do a straight. This one has got a bow to it, so obviously I can't do it that way. So let's just do there. I'm just doing the bare minimum here to show the point. Then I'll turn that back on and get out of the sketch. Turn the mesh off, trim surface, and I'm going to use multiple sketches here. I just use that sketch there, target body this, keep that, there we go. Then from there, we can go ahead and thicken it. Now, here is another point. I know I'm front-loading some of my tips and tutorials before we do the rollback here, but some of these things that I want to show directly as at the beginning, you know. So sometimes when I have a part like this, I look at this and I want to thicken it, but how thick do I want to thicken it? I don't know necessarily. And there's a bunch of different ways you can go about making down and dirty measurements, or quick measurements, is probably the better way to describe it. Is one of them, I can just come over here and say measure distance, and I can come in and I can say no alignment and just click a point and another point and go, okay, it looks like it's around 3.2 millimeters ish. And you see that where I clicked was highly dependent on my alignment to the screen. So sometimes I'll do what I consider sketch-based dimensions. So I'm using the mesh sketch just to come in and accept just really fast there. And sometimes I'll create it. We'll just zoom to the other side here. And I might just come in and fit some geometry, like fit this geometry, fit that geometry there. and say, what is that dimension here? How thick is that surface? So you see 3.3. So I just created a 2D dimension sketch, right? And I can also come back and verify it, right? Now in 3D, I can come back over here and we'll just double click on it. And I can just in 3D look at it right there. And let's just dimension that. You see how I'm just kind of quickly, okay, so right there, that's a 4.4 ish, so I'm just measuring different ways and figuring out that thickness. And this isn't the best example I'm showing ever, but you see the concept is basically just using a dimension sketch. That dimension sketch is now utilized for me to come back and just come over here and say, I want to thicken this surface and I want to thicken it 4.4 millimeters. So come over here, 4.5. Let's do 4.5. Zoom in, make sure my direction's right. There we go. Turn on my solids. And by default, a lot of the, when you are selecting surfaces, it's set to merge a lot now on a lot of the operations, just so you know. So now I have this solid that I've thickened. And so the couple things that I showed here is using 3D sketches very quickly to trim the surface, using 3D sketches really quickly to draw out. So I could have modeled it this way by just drawing the 3D sketch instead of a mesh 3D sketch to create my boundary surface as well, to create this guy that we thickened instead of using the loft wizard here. And then using dimensional sketches. So now we'll go ahead and just get rid of that and just keep rolling forward. So just some of the skills that were utilized for modeling this. So we'll just roll forward here. And there's where we did our thicken there. And let me just hide that other one, that other surface, and hide some of these sketches. Do a little tidying up. Now, here we go for this guy right here, this beam. The method we used is we went ahead and sliced a cross section through right there. Normal to turn that off. And we went ahead and drew the cross section. The other thing we did is if you just maximize this sweep, you can see that we did two different sketches. So we did that sketch and we did this sketch. So this sketch is a following sketch. And we'll just rotate it around here, where we went ahead and drew a guide curve. Now, one thing about the method that we used for this is when you come into spline, by default, it has fit polyline. So you see here with default fit polyline, what's happening as I click. It's fitting the polyline with this many nodes to all of the geometry that I select, which is awesome. That's a crazy cool tool to be able to fit splines very quickly. But with this method here, we don't, a lot of times I'll just turn that fitting of polylines off, and I'll just manually select where I want to draw here. So I'm going to just manually draw and snap. So it's very similar to what I just did in 3D with the sketch tool. And I can manually draw and extend where I want to, but a new feature in the latest DesignX is, in the past with splines, we did not have the ability to extend, but now we have the ability to extend them. So if you come over here to extend, I can trim extend, like if I just draw a line over here. Back in the day, this did not work where it would extend or corner trim as well. So we'll just do this. This is another method. I'm just showing that these exist. So if I had a line there, and I say I want to do a corner trim still does not work, but the trick to it is go ahead and do an extend in that way, right, where you can come over and say extend up to. So that's another method that you can do with splines. And now there was something else associated with those that I was thinking to bring up, but maybe it'll come up later. But the idea here is that I turned off the fitting to create this, and then we just drew a nice, beautiful spline through there that's going to be the guide curve for this. So after we do that, you'll see now I have that solid there. Now let's just keep rolling. And because this fuselage is trimmed off in different ways, I went ahead and we're trying to model it as built because we're using this to model for the display. So we went ahead and fit the surfaces to there. So you see here we just fit that, and we went ahead and fit the other side, I believe. We're just going to hack those off with some surfaces here and then do a cut. Now let's see where we go next. Go ahead and turn that off. Okay, so now we did a mesh sketch for the end here. So these beams have hole cutouts. So drew a hole cutout and went ahead and drew, because these were different hole cutouts, so we drew another one there. We went into a 3D sketch, did a convert entities on the edge. And once you do the convert entities on the edge, then we went ahead. Oh, before we do that, we patterned this over in that direction. So that was I was jumping ahead here. I was thinking about patterning this, but we jumped and we patterned the beam across. Then here we go, we patterned the hole cutouts we patterned it along the guide here. So you can use, as long as you're using the same curvature shape, we used an edge here. You could use the edge. From my experience, finding the closest edge to follow. And then in that curve pattern, we said transform along curve. So its orientation to that curve will follow along that. And you see that we only did a few. So this is one of those examples where it has a partial pattern. It skips over an area. Now you would think, oh yeah, let's just keep it up. But then the pattern interval is different. Everything's different over here. So we were able to do that and cut those away. Jump forward over here, pick it up manually, and cut those away too. So now you see that we've created those. Now, I would have done these, then patterned them across, but the cutouts over here are different, of course. So these are a different shape of a cutout because they have these angle iron pieces as well as these bent shapes. So you see here that we have different shapes. So we go through the same process we did before, where we model the pocket, then pattern it and boolean it, and then repeat that same step. So like we talked about before, this one it's not super complicated. It's just a high volume part where you're modeling and modeling and modeling lots of different things here. And then over here, what we're doing is this beam is actually broken into two. So after we patterned it, we broke it and machined away the pieces. You see that? Then we come over and we got another sweep. So this beam is completely different. You see that we swept it along the top curve like that. And then we did it for a bottom piece as well. So I'll just rotate it around and look at that. So there is a top piece here and a bottom piece there that come together. Now on the inside, it's actually separate pieces for the bottom piece. So just jump forward here. Oh, before we do that, we trim the edge, trim the ends. So trim those ends off. Let's turn off some of our pieces there. Then we did an offset surface there. And now what we're going to do is take a second. We did an offset surface. Roll forward here. So we have that surface offset. We have went ahead and did a extrude. You'll see here, there's this bolted on component right here that we're modeling. Cut those and thicken it. So now you see that we have this component there too. Jump forward. So what we did over here is we started modeling these brackets. So we extruded it and as a surface and thickened it. And again, this one's different from those other ones. I know because I fit it and tried to pattern it and was messing with it myself. So then you discover like what works and what's not actually a pattern. You have to model it as a separate instance. Now, what we did here is we just took a slightly different approach. We said, hey, let's calculate a polyline. Let's try that. And calculate create a vector out of that by just creating that 2D sketch, or a 3D sketch, and just drawing a curve on it, and see if I sweep it along that, will that create a nice clean surface as well? So that was a different method that we used there, instead of just employing some different methods for creating it. And then pattern that along the way. Now over here, the inner I-beam is cut into separate pieces. So we extruded these separate shapes and used those as a cut to create a cut for those pieces. Let's see where we go next here. Modeled that one, went back and modeled that, cut the end piece there. And then work on the other side. So we'll go a little faster through this because it's the same process of that's one pattern, model this one, that's another pattern. And what we discovered is there were some issues where these were different. So the modeling the part, and you see here that this in the pattern, like one instance was different, like this is wrong or something. And in this instance, we're trying to model it relatively close to what's existing condition. So you make decisions along the way of, do I want to idealize it and model it so it is a perfect pattern, or do I want to come back and make changes to it and model it in its existing condition? So now we come back and there are these joining brackets, and we fit those. These joining brackets have multiple steps here because it's a bracket that goes across, then it cuts away. Did a move face there. Cut it from the side. Cut it from the top. Apply fillets and then pattern. So you see that bracket there. Now over here, slightly different approach this time to demonstrate a different way of going about doing it. Fit surface and thicken, and do your same cutaways there. It's got a stair step. Cut away the top and then pattern. Now let's roll forward a few steps. Now the windows. So in this instance, we went ahead and turn these on here. So one thing that comes in really handy here is as you're rolling around, you see you have occluded areas. If you want to work on this flange, it's a little difficult. So keep in mind that we have the view clip, and you can utilize the view clip inside of box, and you can come over if you know that you're just going to focus on this area for a while. Now, accept that. Let's roll forward here. And there we go. I'll stop for a second and kind of explain what happened here. So if we zoom in and turn off the mesh, you'll see that we went ahead and extruded that top surface. We did a loft wizard fitting to that top. One thing that I did on the bottom here is we grabbed this surface, that big surface that we created at the beginning, and we did the typical offset 0. So what that means is we fit a surface to the top, we did offset 0 for the bottom, and then we have this for the sides. And what that means is we can now do one of the most obscure commands in the software, the one that I find that people do not know that we have, is this one called Solidify. So roll forward, and so now I'll turn on the surface, the solid there. So if you have surfaces that would all trim together and form a solid, that's what the Solidify command is. So if you have a surface on the top, bottom, and sides, like we were talking about, and you select all of them and run the Solidify command, it will create a solid. Now, one of the ways that I created those side surfaces on this is a little bit different. You can come in and you can create a region for the side of this part and then do a mesh sketch selected regions only and then draw it, right? That's one way to do it. Another way, just this is kind of just a shortcut way, is if I come over to that same 3D sketch tool that I was talking about before, and I come over to spline, and I just come in and click, and sometimes I can do this faster than doing the other option of creating a region on the side, especially when I'm missing data like this. So what I did here is we just went around the entire thing. I'm just trying to go fast so I can get it all the way done. And again, a 3D mouse comes in handy for this because I'm able to just zoom, rotate with my other hand and do this really fast where I can just pan all the way around and barely move my mouse actually. So you don't have to do it that way. And I did it very quick and sloppily. But you see there, I don't care about the height of it, and I just want to select the best data. And then what I did is you just grab this plane, you just get out of that sketch, grab this plane, you could just do a regular sketch, and there's a bunch of things you could do. You could just do a convert entities if you really wanted to, just select all this convert entities, or you can just redraw it like you would if you were doing a mesh sketch, right? And come in and just draw this, add fillets, and go from there. So that was the approach that I did. Whenever I have some sort of narrow surface like that, that'll take longer to make a region than do anything else. Sometimes that's the easiest thing to do is create something like that. Now, we'll turn these back on, hide that mesh, roll forward. So now on this piece, we went ahead and, let me get out of that. I didn't mean to click on that one. We went ahead and created this, and all that is a silhouette. So if you edit that, you see here, we just silhouetted the hole in the middle and extruded that shape. Then we went ahead and from the side did a silhouette surface there, cut that top surface, Boolean these together. This was actually just an experiment. Here we just did a loft in there just to figure out if we wanted to model it that way, um, and extended it out. And that Boolean, we went ahead and Booleaned all of that stuff together. So if I just roll back, so Boolean all of the pieces together, and a new command that we have now, you see that we did a Boolean, but the tool is still sitting there, is inside of the Boolean command. I'll just make people aware again that now inside of the Boolean command, we have the option to keep the tool bodies or keep the target bodies around in case you need to use them again later for other things. So that is why that Boolean solid is, we Booleaned it away, but yet this guy is still there. So if I just turn that off, and we added a chamfer, so you can see there, roll forward, and there was a tab around the outside. So if I hide the solid show, there is a little, this guy right here, not a tab, but like a band that goes around the outside. So we went ahead and did a extrusion. Then we extruded from the top and did a Boolean intersect between those two shapes to create this. Now we went ahead and cut away. We used that secondary tool, the one that I kept the tool entities. I used that, and then now merge all these together. And move some of these components over to the other side. So let's go ahead now and turn off that view clip. And move some of those things, transform some of those things over to the other side. And then when we transformed some of that over to the other side, we discovered that some of that was very, very different. So this window is very different from that one. The only thing that was the same is the hole size. So in this instance, we did the same thing here, where you see that this also has a recess. So we wanted to know where that recess was. And again, you're not going to cut, this isn't flat, so you're not going to cut a mesh sketch through it. So just draw 4 straight lines on the side as a reference for where those are. And we'll hide the mesh, turn on the surface. Let's turn the surfaces on and show those. So we did a surface offset there, which you can see is a 0.7 surface offset. We did an extrude the solid up to that surface, and that solid was created using this sketch right here that we extracted from those 4 sides. Now do a Boolean away, turn off surfaces. So now we just created that indent there. Now we're going to create the actual window flange like this, because this one is very different from the other one. Extrude up to surface like so, and then we did a cut with surface like that right there. And then from there the same steps follow. Same approach there. Boom. So hopefully this was helpful today. It's a little bit different approach, just trying to show some different tools that people may not have seen, and show some different techniques that people may not have seen on what looks to be a very basic project, but it gets more difficult because it's very repetitive and it's a larger object that has patterns and things, and how to follow the patterns of the object and do it in an accurate way. So with that, we'll go ahead and jump back over to the PowerPoint. I hope everyone has been enjoying the RE Lab webinar, and I'm always striving to make it better and gather input from a variety of sources. And I had the idea to create a survey and put out a survey just asking for feedback. Mainly the feedback is just to gather data points on the topics, the applications, and if there are any other ideas of applications that people might like us to focus on, and just kind of get the pulse of what you guys like to see, what you like to hear. So this is a very open forum. It asks for some feedback and suggestions, and we'll go through those and implement those. So if you have any proposed topics or things that you might want to learn about DesignX, then go ahead and scan this QR code. It takes you straight to a form, and we will take that and implement it.